Hi folks, welcome to Build and welcome to our session on Azure Timeseries Insights titled Make Your IoT Data Useful with an End-to-End Analytics Platform. I'm Diego Viso, I'm a Program Manager here on the Timeseries Insights team.
And my name is Deepak Pallade. I'm a Program Manager on Timeseries Insights team. Welcome to Build.
In this session, we'll cover the following topics: an overview of Timeseries Insights, key capabilities and features, customer scenarios, the architecture for Timeseries Insights. We'll also go through a demo and we'll finish off with our roadmap. So let's start with what Timeseries Insights is. Timeseries Insights is an end-to-end analytics platform tailored towards the unique needs of industrial IoT. So what does this exactly mean? It means that we're flexible and built for scale. We ingest billions of events across hundreds and thousands of data points, giving you the ability to tap into your massive volumes of data to unlock insights not previously possible. Let's talk about the attributes of IoT data which help guide our design principles. So firstly, IoT data lacks structural consistency. We typically see unstructured or semi-structured data, which has very little context about what the actual data means. Second point to that is IoT data needs contextualization. In order to derive insights out of this data, we need to better understand how this data relates to each other. For example, what are the relationships between the sensors? How far is sensor A from sensor B? These are the types of questions that we need to be able to answer. Thirdly, IoT data requires near infinite retention. So in order to gain operational intelligence, it's well known that the more historical data you have, the better your insights will be. And finally, IoT data is useful when combined with other related data sets to ensure an organization has a holistic view of their data landscape. So with this in mind, how does Timeseries Insights solve these challenges? Let's start by sharing that Timeseries Insights is a fully managed PaaS platform built for IoT. Because we are a PaaS service, you can build applications on top of us, or you can use this as a turnkey solution by leveraging our out-of-the-box TSI user experience. Now let's break down our key value pillars here. First, we ingest, store, process, query, and visualize data at scale. We're talking about billions of events across hundreds and thousands of devices. Second, we are open and flexible. We allow you to connect your data with other analytic solutions by leveraging the open source format of Apache Parquet and storing this data in an Azure storage account that you own. Third, we have a rich set of APIs and a UX experience that is first class. It allows you to derive insights very quickly, and in fact, everything that's done in the UX can be done by our APIs, public APIs. There's no private-facing APIs that we leverage for our UX. And finally, we have an open source JavaScript SDK library, which allows us to create the TSI look and feel within your own applications. It provides components such as charts and functions to access the time series data, so you can tailor an application experience for your particular use case. This is built on top of a scalable platform that ensures that when you grow, the service grows with you. And we're also pay-as-you-go, ensuring that you only pay for what you use. Next, I wanted to spend a little time to highlight some of the key capabilities of Azure Timeseries Insights. Firstly, we provide multi-layered storage, which allows you to have a tiered storage experience, warm for highly interactive recent data, and cold for historical data that spans decades, giving you, which is great for great advanced analytic scenarios. Second, we have a flexible platform. As I mentioned, we write in open source efficient Apache Parquet file format, and we write this in your own storage account, allowing you to connect to other analytics tools of your choice. We will over time provide native connectors to platforms such as Spark to make the integration experience seamless. Next, as I mentioned, we have a rich set of query APIs and a UX which is feature-rich and includes things such as support for interpolation, scalar, aggregate functions, categorical variables, scatter plots. It's truly a first-class citizen for TSI. Next, we're enterprise grade. We're ensuring that we meet the high scale demands of our customers. And finally, we have rich extensibility. We have a Power BI connector, which allows customers to combine related data sets to get a better understanding of their data landscape. What I wanted to do now is share two real-world use cases with you to give an insight on how our customers deploy TSI in an end-to-end scenario. We are used across a variety of industries, including manufacturing, power and utilities, oil and gas, automotive, and agriculture. In this example, I wanted to show you a manufacturing and a smart buildings use case. So starting off with manufacturing, manufacturing customers are generally trying to gain operational intelligence and improve their products. This is all about high fidelity analysis of the manufacturing process, comparing results across batches. The aim is for a manufacturer to figure out what makes a golden batch and what is affecting product quality and how do I make better products. So in this particular architecture, starting from the left, we can see we have a bunch of industrial IoT assets. These IoT assets usually speak multiple protocols. We have protocols such as Modbus, DF1, Profinet, OPCDA, and what we aim to do is unify those protocols in a way that we can actually ingest them. So what we ask customers to do is deploy a gateway. Generally, it's an OPC UA gateway that we ask them to deploy, and from there we ask them to deploy an IoT Edge server on the plant floor. The IoT Edge server will actually take data, work in conjunction with the OPC UA server to do the translation and create the JSON files that we actually consume as part of our platform. This goes to IoT Hub, and typically what we see is two paths here. Some customers will actually build a hot path to do advanced stream processing. These are things such as doing derived time series, taking two particular pieces of time series, combining them together. That derived time series will drop into Event Hub and then be consumed by time series insights. The other scenario we see is customers will run some sort of conditional logic here, and based on the result, they'll actually trigger an Azure function to drive some other action. From IoT Hub, then we have the warm path, which is where time series insights consumes that data, and then using hierarchies, types, and instances, we can start to visualize that data and derive some insights. Everything is built on top of a query API, so customers can then visualize that data within their own custom applications. They can use TSI Explorer, or they can go ahead and use Power BI. The other stream here is customers can take that data, as we discussed before, everything stored in Apache Parquet, and use their advanced analytics tool to do things such as building predictive dashboards. The next use case I wanted to share with you is a smart buildings use case. One of the goals of smart buildings is to drive energy efficiency and promote sustainability. A key contributor to energy inefficiency are faults. So the quicker these faults are detected, the greater the efficiency, hence why being able to detect anomalies and faults within the building are critical for energy efficiency. So in this particular architecture on the left-hand side, we have a building that has multiple assets, including things such as HVACs, VAVs, boilers, and chillers. All of this equipment generates telemetry. What's typical to see in a smart building is a building management system which aggregates all of this data. We then have a gateway. In this case, it's a BACnet gateway. BACnet is the typical protocol used in facilities management. And this gateway does the translation from BACnet to something we ingest, which is a JSON payload. Again, it goes on top of IoT Edge. IoT Edge sends that up to IoT Hub. And what we sometimes see within smart building deployments is customers will re-enrich this data with some additional data about that telemetry. And it can be information around the equipment itself, or it could be, for example, the building that this telemetry is originated from. So there's an enrichment step there that's delivered through an Azure function. This data is then ingested into Event Hub, and two paths, again, this hot path and warm path, where the hot path, we see telemetry being run through a rules engine that based on a particular condition will trigger a function. And then in the warm path, the data will be ingested in time series insights to drive that intelligence and to do some trending and anomaly detection and things like this. Finally, I just quickly wanted to talk about our customers. We have many customers across different industries, including manufacturing, oil and gas, automotive, and energy. And we're keen to work with our customers to see other requirements that we need to make in the platform to ensure their businesses are successful. So definitely get in touch with us. We're here to partner with you to ensure success. And with that said, I'm going to hand it over to Deepak to cover the product in a little more detail.
Thanks, Diego. Now let's look at the Timeseries Insights architecture. So if you look at, all the components that make up the product, the first thing if you notice is, hey, how will we get the data coming from the edge? There are multiple ways through which, customers choose to ingest data into TSI, one of which is coming through IoT Hub, and one method through which, they choose to ingest is via Event Hub. And in future, once ADT goes live, that is another method through which, we will be getting telemetry and context information coming into TSI. So from the perspective of like all these core components, from IoT Hub, what we do get device telemetry, and we process that using our stream processing engine. And then depending on the customer configuration, we either route it to warm store or cold store. And our cold store is based on Azure Data Lake, and we support Apache Parquet file format in which we write the files, and customers can store it once and reuse it across the Azure ecosystem. And we have this notion of modeling within TSI. What it does, it helps us create context, as well as it helps sync the context coming from the upstream systems. So essentially, time series model has three components. You have this notion of instances, which are the representation of your time series telemetry as well as time series themselves. Then you have this notion of variables. The notion of variables are part of types, which helps you classify all these telemetry items that are coming. And then you have hierarchies, which helps you organize all these instances in a meaningful way that way you can triage it. So in the long run, what we want to do is we want to have this model auto-populated, looking at what you get from model information from Hub as well as from ADT. That's the reason you see from ADT you have a digital twin model that gets auto-populated here, and from IoT Hub you have a device twin model that gets populated. And then comes the query layer that Diego was talking about. The query layer tries to give a unified experience for our customers when they try to query data stored in warm store or cold store. Warm store for us is based on ADX, and in warm store, customers can choose to retain data of by X number of days. Like, hey, if you have the need of storing the data for 30 days, you can store all the data that comes in into warm store, and then rest route everything to cold store. So today when the data gets into Hub, and when our processing engine processes the data, it stores in both warm and cold, so that cold is your master copy of all things that you have so far collected or accumulated in the environment, versus warm store being last X number of days depending on your configuration. And query, what it does is it tries to go to warm store and cold store depending on the request body or the request header that you have, and it tries to retrieve the information. And similarly, TSQ even helps you query the data coming from time series model. That way, you can query context as well as telemetry that is coming from these stores. And then, our queries today used in our TSI Explorer. Later in this presentation, we will go through, some of the features that we have available there, as well as, TSQ is used through, our endpoints in third-party applications. Customers can take the goodness that we have to offer through these APIs and integrate them directly with their line of business applications. And they say, hey, how can I enable CRUD directly from there? That way, right, they can integrate the API layer within their operation system. Then you have Power BI connector that we have, which will let you take the data coming out of TSQ and integrate that with the rest of your ecosystem. So customers can say, hey, I have this time series data stored in TSI. Now I want to take this information and connect that with maybe ERP information or CRM information. They can do that seamlessly using Power BI. Then we have this whole notion of things that we are working on, like for example, Calc Engine and Job Engine. If you look at it, Job Engine helps us do operations, batch operations, essentially loading the data on the historical data, essentially bringing it from the lake and making it useful within the context of TSI, as well as in future it will help in batch querying, because right now it is interactive. TSQ, in synchronously it goes and queries the data, but in future we will support scenarios where it will end up enabling batch query scenarios for our customers. And we do have our Spark connector, through which customers can take the data that is stored in cold store and integrate that with the line of business applications they have, or like any downstream, upstream analytic solutions they have. So in a nutshell, this is what architecturally TSI enables. Now, quickly jumping on to the queries I spoke about. From querying perspective, we have queries classified into three categories. Environment APIs essentially lets you go and do operations on the environment. Like, hey, how can I understand what are the environments I have access to? Or, hey, what is the distribution of the data within the environment? How can I understand the event schema of the data that is there in these environments. So all the things that has to do with environments are classified under environment APIs. Then you have time series model APIs. So time series model APIs enable CRUD on the model itself. So customers can use these APIs and directly update the model without coming to our UX. Where they can say, hey, how can I go and update the types or the variables that are stored within the types? How can I update metadata related to the instances? That way I can provide more context to the instances. And how can I go and organize my data in a hierarchical manner? That way I can use this API and seamlessly do it. So this is the second category through which customers can go and query the data or update the model. Then comes the time series query API. This is where the most of the data is computed and is retrieved. If you look at it, today we have three APIs. Get events essentially is used to get the raw events. It takes every API again has a different payload depending on the configurations that you provide to the to the request. The response you get the response accordingly. So from a get events perspective, it is just a raw data telemetry API. And get series and aggregate series are our aggregation APIs. This essentially takes set of points, and per interval it tries to reduce the point depending on the formula that you have stored in the notion of variable. As we go to the demo, I can show you some of the variable definitions. That way, this becomes even more clearer. So if you look at this is our landing environment, time series insights preview. If you click on the environment once it is provisioned, you land on our Explorer. So once the environment loads, it shows you a list of all the environments you have access to depending on what you want. For this demo purpose, let's say let's use this environment, Contoso Fleet Time Series Analytics. This is an environment that we have set up in which Contoso Fleet Management Company is using this TSI product to manage the fleets that they have leased to all the customers. So here, if you see in this experience, you have two panes. One is the model section where you go to author the model for the environment. The other one is analyze, where you come and analyze the data that you have modeled. So now quickly jumping on to model. In model, you have three categories. Let's start with the instances. Instances essentially are your virtual representation of time series within TSI. So anytime there is a new instance that is discovered on the hub that is configured for TSI, we automatically create an entry here, and here customers can come and customize the data and provide more context to it. Like, for example, they can come and say, hey, I have this instance for which I want to add instance fields. These are static properties. And this will be used to explore the data and understand what are the characteristics of this data going by the value that is provided for these instance fields. So in future, what we aspire to do is to connect this directly to the property metadata that we get from Hub and Digital Twin. So as part of our evolution, these will get synchronized for product experience. Now, instances again, are the telemetry themselves, where you can use them and say, hey, how can I explore this particular tag and derive meaning out of it? Then what you do, you take those instance fields that we spoke about, and you create hierarchy. Here, if you see, we have created a hierarchy called delivery truck operations ops, where you have the first level to be country, lease to, manufacturer, year, and make. So all of these are coming from the instance fields. If I go back here for one quick minute and show you the instances, these are the telemetry fields. Like, you see here, hey, you have make, year, manufacturer, country. So what our UX does is, it leverages the power of TSMQ, time series model query, and it builds this hierarchy for customers to understand how they have organized the data. That way, exploration becomes seamless. So hierarchy helps you think about hierarchies as helper, which helps you organize your instances. Then comes, types. This is where, you classify your sensors. Let's say you take all your temperature sensors and you can say, hey, there is a type for temperature, and you define, computation around temperatures for that. In this case, what I've done is, we have created two types. One is performance analytics type, in which, I have a bunch of calculations that we are doing, leveraging the incoming telemetry. And there is another one, which is default type, in which I have a bunch of calculations as well. Now, quickly looking at, what we do here. Let's take, a simple example. Let's take average speed. If you see in variable definition, what we do with average speed is we select, hey, what is the name of the variable and what is the value that I should refer to, which is coming from the telemetry that the hub is giving to Timeseries Insights, and the type of aggregation operations that I want to do on that, and then say, hey, you know what, I just need to do this and save it. So that is your average speed. What it does is it stores the formula and it just leaves it there. And then when you run this on the runtime, that is when this gets calculated, pointing to the telemetry that is stored in our storage. We will show that in a minute, and we will quickly look at another example. Let's say road slope. This is a complicated expression, or it's a complex expression where you have trigonometric functions that you have used to create the road slope. Again, it uses the notion of the event and the altitude that is coming from the event, and the longitude and the latitude coming from the event, and it calculates the road slope on how the truck was, when the truck was driving on the road, what was the road slope, and try to compare that with the speed of the truck. Now, what we want you to take away with this is types help you classify your tags or time series instances, and it helps you define computations on them. That way, right, you don't have to repeat that. So the thing that we try to achieve with TSI is we don't do any pre-compute. We always look at the data and use the definitions that we have stored in variables and explore the data. Now, here, we created two hierarchies. Anything that is not associated to these hierarchies will go under unassigned time series instances. That way our customers can come and even model those. Now let's pick up, delivery truck ops, in which I'll go to Brazil. I'll go to, hey, let's look at all the trucks that I have leased out to Adventure Works Transport. And within that, I'll go to Falcon, make, year, model, and these are the trucks we have. Let's say, for this truck, I want to see average speed. At this point, what happens, our query takes the time, you go and click show average speed. At this point, our query takes this request, goes to the backend, gets the data, uses the formula that is stored in average speed that we looked at, and tries to calculate and give it to our Explorer. That way it gets displayed here. So quick thing here on our Explorer, if you see anything that is in this orange range is the warm store. And anything that is beyond the orange range is essentially our cold store. So you can easily switch between warm and cold store using this option as well here. Or you can say, hey, you know what, I want to use warm store as much as I can, and only for additional analytics, I want to go to cold store. So what we did here is we plotted the variable, and because the search span was within the warm store range, the query came back as soon as it could. So if you see, let's say I want to go and say, hey, show me the road slope. And now let me see, okay, this seems interesting. I can zoom into the section and say, how can I ask questions around, okay, what was my speed of the truck when the road slope was varying? Is there any correlation that I can do? And then you can start adding additional things like, friction force. You can say, hey, all of these are again, coming from the definition of variables, and these all are runtime compute. We are calculating these formulas at the runtime and determining, what to display. That way, we don't pre-calculate anything and store, within our data stores. And you can say, hey, now this is interesting, but let me do one thing. Let me go and use these three variables and try to explore data for last almost a year now. let's say, if I want to do that operation, you can easily go and issue a query, something like this. And what at this point it does is it takes these three variables, it goes to our cold store, and it tries to get all the data, compute it, and retrieve, signals for us. That way, you can go and plot it. If you see, in a couple of seconds, I think 7 seconds, this data came back. Now you can see the trend of these three variables over last 320 days. So in a nutshell, there are like bunch of features that are available from our UX perspective. You can convert this into a heat map, and you can visualize that. You can change the intervals to whatever interval you have. Instead of 12-hour interval, let's say you want to do 8 hours interval, you can definitely go and do that. And then you can also take this data and you can say, hey, I want to download this and send it to somebody within the team. That way, right? I ask a specific question that I need to answer. Or you can, even take this data that is available and integrate that with, Power BI. That way, when you click on this option, it gives you it gives you the ability to say, hey, do you want to take the aggregated data, or do you want to take the raw telemetry that is coming out of it and then, connect it to Power BI? So these are the things that we are planning to release as part of our GA, and there are like bunch of other things which you can try by going to the link that will be available in our documentation. And if you just add /demo to it, this is the demo environment where you can go and get your hands on. Now that was the demo that we wanted to show you, and now let's quickly look at the product roadmap. We will talk about what we are working on right now as we speak. Warm and cold-based analytics that we just reviewed, that is being worked on, and it is all ready for our GA. Then we have time series model and time series query API, additional capabilities that we are adding to it from scale as well as from additional aggregate and scalar functions that our customers can use. We are revamping our user experience, and we are providing additional capabilities around like, hey, how can you go and do auto refresh of the data? That way, anytime there is new data, you don't have to do anything. The charts that are already there gets automatically refreshed. You have the notion of categorical variable where you can go and explore categorical signals. That is something that we are working on, and that is available as of today in our demo environments, as well as it will be part of our GA. Then Power BI Connector, we briefly reviewed that. That is something that we are super excited about, because that opens up a lot of avenues for data integrations for our customers. Then we are working diligently on Azure Data Lake storage Gen 2 support in public preview. Again, we want to support this in a preview format and then go from there. Then the next thing we are adding is AAD group support. That way, the ACLs are managed via AAD groups, making it easy to manage them. The next thing is enterprise readiness. We are going to new regions. We are scaling the product to support, enterprise load as well as security. And, we are working on a framework to import data such that, customers can bring their existing data and, start using the power of time series insights in parallel to, the new data that is being streamed. And the last thing is essentially the Spark connector for advanced analytics, where you store the data once in TSI and then use the Spark connector and integrate that with all the downstream Azure ecosystem for analytics. And from what is coming next perspective, there are tons of things that we are working on next, and we are super excited for where we are taking the product. Some of those things include how can we get better at improving the latency lag and the transforms for the data that comes into TSI. Today, we support basic processing of data, but we want to go and double click on that to say, hey, how can we enable customers to go and do meaningful transforms? That way, they cleanse the data and they store it in a meaningful way, as well as improving the latency and lag for the data. The second thing, and one of the important things for us is how can we get better at integrating with the ecosystem? Like, how can TSM get better at understanding PNP and ADT natively? That way, customers don't have to reconfigure anything. They configure it once, and all these products, they understand each other, and things start populating automatically in these experiences. OPC UA binary and CDM support is another thing that we will be working on just to complete the story around analytics and how can we have all of these supported end to end. There are a bunch of query updates that we are working on, like how can you enable composition. That way you take a bunch of time series and try to combine them into one and derive a metric for it. And new scalar functions and aggregate functions. We are thinking of exposing Kusto query language on our WOM store. That way customers who are familiar with the language can easily use the power that KQL provides. Data updation and data deletion is the top of our mind because that is one of the highest asked customer request, and that is being worked on next. Connectors. How can we add more things to our connectors, and how can we expand our integration stories with connectors with EML, Spark, and Databricks. There are a bunch of new analytics features we are adding, like process graphics, dashboarding, and all the SDK updates. So one thing what I noticed that we did cover as part of the architecture is what power the SDK, JavaScript SDK that we have bring to the table. Our JavaScript SDK can be used, and it can be integrated with any of our customers' line of business application. That way, whatever charting features you have, that can be used within these SDKs. And we'll be adding, as and when we'll be making new improvements to our user experience, we'll be adding those features to our SDK. That way it can be leveraged by all our customers. And then we'll be adding new security and compliance features for role-based access control, things like, hey, how can we have tag level security? We'll be exploring that next. Migration of TSI Gen 1 to Gen 2. Essentially, all the customers who are on Generation 1, how can we give them a meaningful path through which they can migrate to Gen 2 and start using the power of the pay-as-you-go SKU that we have here. And the TSI on Edge is another important thing that we have been focusing on, detailing out. So that is another thing that is being worked on next. Anomaly detection, forecasting, and predictive maintenance are our advanced analytics scenarios. This is something that we want to make natively available within TSI. That way customers can use this and do complex event processing or reactive processing depending on their scenarios. And disaster recovery. It goes back to hey, how can we support BCDR for our customers, business continuity and disaster recovery for our customers, and bunch of updates to our SDKs. Like, hey, how can we build new SDKs? That way it is easy for our customers to take these and integrate that with their applications as well as their CI/CD pipelines. So these are some of the things that we are thinking of doing next. And as we proceed with the roadmap, we will keep you guys posted on how we are making progress. And quickly jumping on to the last thing, these are the resources that you can use in order to learn more about our product. And we look forward to hearing back from you on where can you take this next. From next steps perspective, these are the list of resources that are available. We think will help you as you traverse through build to become Azure IoT certified. Training we have trainings as well as exams, and these hyperlinks will help you get those. And we do have IoT shows as well as how to get started with Azure IoT. That details out what our products can enable and what scenarios can you go and solve. And you can join our tech community as well as attend other build sessions that we have. That way you get to understand what is that we are thinking from Azure IoT perspective. So Microsoft IoT vision and roadmap is something that is there on May 19th, as well as IoT live coding session that is on May 20th.
Thank you so much for participating in our session. Make your IoT data useful with an end-to-end analytics platform. We hope you've enjoyed the overview and the deep dive of Azure Timeseries Insights. And we hope you enjoy the rest of the build session, and please get in touch with us. Thank you.
Thank you so much for attending our session. We are looking forward to seeing what you can do with this product and what scenarios you will solve for yourself as well as the customers. Thank you.